are we going to use all of this? Well, when an object is spinning a circular path of radius 2 meters with velocity v, in meters per second, the centripetal acceleration a, in meters per second squared, is directed towards the center of the circle. Yeah, what does that mean? Okay, so basically if you have something going around in a circle, say you're driving, and all of a sudden you make a curve. When you make the curve, you drive part of a circle. And so your normal velocity that's going straight forward has to change directions, and so you have to accelerate in a new direction. And that's why you feel like you're being squashed against the outside of your car, because of that acceleration force. Because if you kept going forward, you would just feel like you were sitting in a normal chair in a room and not moving at all. But as soon as you change directions, you have to have an acceleration applied upon yourself, which is a force going in a different direction from what you normally were going in. So this is all well and good, but how is it used? Well, you got your traffic directors who hire mathematicians like you and I to go figure out how fast you can actually take a curve safely without rolling your vehicle. Or when you design roller coasters, you need to figure out how fast you can go around a curve or up and down or go in loops without actually squashing someone's brain. So here's a more simple explanation or problem than what you would do in the real world, but it's kind of real world-ish. The velocity v and acceleration a of an object are related by the function v is equal to the square root of 2a. And again, our circle here is got a radius of 2. If we just wanted to simply graph this function, state the domain and range, we'd be doing something similar to what we did in the last videos. So you know that this has got no shift of any kind. It's not going up and down or side to side. So we are going to start at the origin, and if I do fill in and make this a and this v instead of x and y, this would be a 0. And if I fill in a 0 for 2, I get a 0 for v. Then I can fill in, say, a 1. So that would be the square root of 2 times a 1, which would just be the square root of 2, and we can just leave it the square root of 2. If I want to fill in, say, a 2 there, then that would be 2 times 2 is 4, and square root of 4 is 2, and I'm back at 2. Likewise, if I want to fill in a 3 right there, 2 times 3 is 6, square root of 6, well, we're just going to leave that the square root of 6. And I could fill in a 4 right there, so that would be 2 times 4 is 8, and the square root of 8. And again, I will just leave that the square root of 8. Then I can start plotting my points. So I've got the point 0, 0. And I know if I go any further down from 0, like into a negative, I would end up with imaginary. So that is my beginning point. And then at 1, I'm at the square root of 2. Square root of 2 is greater than 1, because square root of 1 is 1. But it's less than the square root of, say, 4, which would be 2. So I'm pretty close to 1 here. And then 2 would be at 2. And the square root of 6, well, the square root of 4 is 2. The square root of 9 is 3. So I'm somewhere between 2 and 3. And then square root of 8, well, square root of 9 is 3. And we're at the square root of 8. So we're pretty darn close to 3, but we're not quite there yet. And so then we can trace in our function. So then we want to state the domain and range. The domain is going to be anything greater than 0, and the range is going to be also anything greater than 0. You can see where we're never going to go further to the left, which would be our negatives, or go further down, which would also be negatives. So the domain, and let me move down here a bit. The domain would be anything greater than 0, and the range would be anything greater than 0. So starting at 0 and going on to infinity. Now, what would be the centripetal acceleration of an object spinning along the circular path with a velocity of 4 meters per second? Okay, so the velocity is 4, and we want to find the acceleration. So that means we're putting a 4 in for v, and then we're solving this. So v is equal to the square root of 2a. v is equal to the square root of 2a. And we want to put a velocity of 4 meters per second. So the 4 is going here. So to get the a by itself, you would have to square both sides. So that means I'm squaring this side and I'm squaring this side. So that becomes a 16 is equal to, and the opposite of square rooting is squaring, so that basically evens itself out and we just get the 2a over here. Then you can divide both sides by 2, and you end up with a is equal to 8. So your acceleration would be, and this is meters per second, so acceleration would be meters per second squared. 8 meters per second squared, or meters per second.